Well, hello, Earth scientists, and welcome to the first video lesson in our Sedimentary Geology series. In this video, we will be learning about the basics of clastic sedimentary processes like weathering, erosion, and deposition. Let's go! So, what is a clastic sedimentary process? The short story is that it's any process that leads to the formation of a clastic sedimentary rock. Now, clastic sedimentary rocks are made up of bits and pieces of other rocks. So what's the long story? Well, when sediment is created through weathering and erosion, it's eventually deposited into a basin and turned into a rock through compaction and cementation. So let's dig in. The sedimentary rock cycle starts when rocks at the surface of the earth break apart physically or chemically. This process is called weathering. Physical weathering is when rocks break into smaller pieces, like when ice and water get into the cracks of a mountain and the rocks break off and fall down in a rock slide, or when a glacier carves rocks off the side of a hill or a mountain. Physical weathering changes the shape of the rock from something large with sharp angles to something littler and generally more rounded. And chemical weathering is when the minerals inside the rock react with the chemistry of the water or atmosphere on the surface of the earth to become more stable. So mafic minerals like olivine, amphibole, and pyroxene have iron and other metals in them that easily react with oxygen and water. When this happens, the metals leach out of the mineral and it becomes more felsic, which means that now it has a higher percentage of silica inside and that rust was created. Chemical weathering changes the chemistry of the rock from something that is more mafic with more metals in it and a darker color to something that is more felsic and has more silica and is a lighter color. Once the processes of weathering turn the rock into sediment, the process of erosion transports the sediment away from the source rock it came from to a new area called a sedimentary basin. So, what moves a rock? Well, wind can pick up small particles like sand and blow them around. Water can move lots of sizes of rocks depending on the current. Gravity pulls big rocks downhill, and ice can actually move really huge rocks around. Eventually, sediment ends up somewhere that erosional agents like water and gravity can't move it anymore. These places are called depositional basins. In these places, sediment piles up. These are sandy, dirty, muddy places, just the perfect place for the birth of a clastic sedimentary rock. The last step in forming a sedimentary rock is lithification, which is just a fancy word to mean that something turns into a rock. Sediment is cemented or glued together and then compacted or squished into sheets and eventually become a sedimentary rock. Compaction happens when the sediment in a basin starts to pile up, and the pile gets deeper and deeper and heavier and pushes the older sediment down with its weight. And as that overlaying sediment gets heavier and heavier, the sediment below gets squished and flattened into thinner and thinner sheets. And the rocks, stones, and sands get pushed together so that there aren't any more big spaces between them. Then cementation happens when groundwater with dissolved chemicals like calcium and silica get into the spaces between the rocks. When this happens, there's a slow chemical reaction that turns those dissolved chemicals into minerals like calcite and quartz, which then bind or glue the sediment together, finally forming a solid rock. And that's it. We start with one kind of rock, it weathers and erodes into a depositional basin where it settles and gets buried. And then after millions of years of burial and compaction and cementation, we finally end up with a beautiful clastic sedimentary rock.